Definition and brief history of IoT. What is IoT? IoT can be described as a branch of the Internet and other networks to different types of sensors and devices, or things. It includes the simple objects like light bulbs, vents, locks, and even things with a higher degree of computing and analytical capabilities. History of IoT. The actual idea of interconnected devices had been around at least since the 70s and was called the embedded internet or pervasive computing. Kevin Ashton, a British technology pioneer, invented the term Internet of Things. This happened when he was working at Procter and Gamble. Ashton was working on a supply chain management optimization and wanted to attract the attention of his senior management to a new technology at the time called RFID. Due to the internet being the hottest new trend, it made sense for him to call his presentation Internet of Things.
Internet of Things, key features. The Internet of Things is a connected smart device technology with a growing number of applications across industries. The need to develop a uniform standard for IoT ecosystems is becoming more important as its use grows across numerous industries. Any IoT device comes with a set of common characteristics, such as connection, analytics, endpoint administration, and so on, as a design standard. Connectivity. The most significant factor to consider in the case of IoT is connectivity. It is impossible to execute any proper business use case without smooth communication across the connected components of the IoT ecosystems. Examples are sensors, compute engines, data hubs, etc. Radio waves, Bluetooth, Wi-Fi, Li-Fi, and other technologies can be used to link IoT devices. In order to enhance efficiency and provide generic connectivity across IoT ecosystems and industry, we can use several protocols of Internet connectivity layers. The IoT ecosystem may be established on premises or through an intranet in some cases. Sensing. Based on previous experiences with various things or events, humans can quickly understand and analyze circumstances. If we want to get the most out of IoT, we need to read the analog signal and convert it so that we can get relevant insights from it. To collect data on a specific topic, we employ electrochemical, gyroscope, pressure, light sensors, GPS, electrochemical, pressure, RFID, and other methods. We use light detection sensors, as well as pressure, velocity, and imaging sensors, for automobile use cases. We must choose the appropriate sensing paradigm to make a use case successful. Active engagements. IoT device connects various products, cross-platform technologies, and services work together by establishing an active engagement between them. In general, we employ blockchain to establish active engagements among IoT components using cloud computing. Raw analog data must be gathered, pre-processed, and rescaled according to business capacity in the case of industry-grade IoT systems. As a result, carriers must address the future needs of manipulating such a large scale of data to meet incremental business objectives while creating IoT ecosystems. Scale. IoT devices should be designed in such a way that they can be scaled up or down easily on demand. In general, IoT is being used from smart home automation to automating large factories and workstations, so the use cases vary in scale. A carrier should design their IoT infrastructure depending upon their current and future engagement scale. Dynamic nature. The first and most important step in any IoT use case is to collect and process data in such a way that business choices can be made from it. Throughout this process, numerous IoT components must change their status dynamically. A temperature sensor's input, for example, will vary continuously dependent on weather conditions, location, and so forth. This should be considered while designing IoT devices. Intelligence. In today's environment, data is used to produce significant business insights and drive important business choices in practically every IoT use case. On top of this vast data, we build machine learning/deep learning models to gain significant insights. The analog signals are pre-processed and transformed to a format suitable for training machine learning models. We must consider the appropriate data infrastructure depending on business requirements. Energy. From end components to connectivity and analytics layers, the whole ecosystems demand a lot of energy. While designing an IoT ecosystem, we need to consider design methodology such that energy consumption is minimal. Safety. One of the main features of the IoT ecosystem is security. In the whole flow of an IoT ecosystem, sensitive information is passed from endpoints to the analytics layer via connectivity components. While designing an IoT system, we need to adhere to proper safety, security measures, and firewalls to keep the data away from misuse and manipulations. Compromising any component of an IoT ecosystem can eventually lead to failure of the whole pipeline. Integration. IoT integrates various cross-domain models to enrich user experience. It also ensures proper trade-off between infrastructure and operational costs.
IoT hardware includes a wide range of devices such as devices for routing, bridges, sensors, and etc. These IoT devices manage key tasks and functions such as system activation, security, action specifications, communication, and detection of support-specific goals and actions. IoT hardware components can vary from low-power boards, single-board processors like the Arduino Uno, which are basically smaller boards that are plugged into mainboards to improve and increase its functionality by bringing out specific functions or features. A programmer specifies a board's input and output, then creates a circuit design to illustrate the interaction of these inputs and outputs. Another well-known IoT platform is Raspberry Pi 2, which is a very affordable and tiny computer that can incorporate an entire web server. Often called RasPi, it has enough processing power and memory to run Windows 10 on it as well as IoT Core. RasPi exhibits great processing capabilities, especially when using the Python programming. BeagleBoard is a single-board computer with a Linux-based OS that uses an ARM processor, capable of more powerful processing than RasPi. Tech giant Intel's Galileo and Edison boards are other options, both great for larger-scale production, and Qualcomm has manufactured an array of enterprise-level IoT technology for cars and cameras to healthcare. The most important IoT hardware might be its sensors. These devices consist of a variety of modules such as energy modules, RF modules, power management modules, and sensing modules. RF modules manage communications through their signal processing, Wi-Fi, Zigbee, Bluetooth, radio transceiver, duplexer, and BAW. The sensing module manages sensing through assorted active and passive measurement devices. Here are some of the most commonly used sensors in IoT.
IoT software. What is IoT software? IoT software addresses its key areas of networking and action through platforms, embedded systems, partner systems, and middleware. These individual and master applications are responsible for data collection, device integration, real-time analytics, and application and process extension within the IoT network. They exploit integration with critical business systems like ordering systems, robotics, scheduling, and many more in the execution of related tasks. Next is data collection. Data collection is a software that manages sensing, measurements, light data, filtering, light data security, and aggregation of data. It uses certain protocols to aid sensors in connecting with real-time machines to do machine works. Then it collects data from multiple devices and distributes it in accordance with settings. It also works in reverse by distributing data over devices. The system eventually transmits all collected data to a control server. Device integration. Integration means making independently designed applications and data work well together. Device integration means making the mix of new IoT devices, IoT data, IoT platforms, and IoT applications combined with IT assets like business applications, legacy data, mobile, and SaaS work well together in the context of implementing end-to-end IoT business solutions. The IoT integration market is defined as the set of IoT integration capabilities that IoT project implementers need to successfully integrate end-to-end IoT business solutions. Data analytics. IoT analytics is an application that helps to understand the huge volume of data generated connected IoT devices. In other words, Internet of Things, known as IoT, is coined by Kevin Ashton, co-founder of Auto ID Center at the Massachusetts Institute of Technology, known as the MIT. In other words, IoT is just an ecosystem, the physical things which are connected to the internet, and we see results through IoT analytics platform. You may also explore more about real-time anomaly detection for cognitive intelligence in this video. For instance, these physical things include smartphones, tablets, wearable device, and sensors. Last is the application and process extension. These applications extend the reach of existing systems and software to allow a wider, more effective system. They integrate predefined devices for specific purposes, such as allowing certain mobile devices or engineering instruments access. It supports improved productivity and more accurate data collection.
Internet of Things, Technology and Protocols, NFC and RFID. Near-field communication and radio frequency identification provide simple, low-energy, and versatile options for identity and access tokens, connection bootstrapping, and payments. RFID technology employs two-way radio transmitter receivers to identify and track tags associated with objects. NFC consists of communication protocols for electronic devices, typically a mobile device and a standard device. Low-energy Bluetooth. This technology supports the low power, long use need of IoT function while exploiting a standard technology with native support across systems. Low-energy wireless. This technology replaces the most power-hungry aspect of an IoT system. Low-energy wireless not only reduces consumption but also extends the life of the device through less use. Radio protocols. Zigbee, Z-Wave, and Thread are radio protocols for creating low-rate private area networks. These technologies are low power but offer high throughput unlike many similar options. This increases the power of small local devices networks without the typical cost. LTE Advanced. LTE Advanced delivers an important upgrade to LTE technology by increasing not only its coverage, but also reducing its latency and raising its throughput. It gives IoT a tremendous power through expanding its range, with its most significant applications being vehicle, UAV, and similar communication. Wi-Fi Direct. Wi-Fi Direct eliminates the need for an access point. It allows peer-to-peer connections with the speed of Wi-Fi, but with lower latency. Wi-Fi Direct eliminates an element of a network that often bogs it down, and it does not compromise on speed or throughput.
A wide range of industries are becoming more productive and efficient, improving their products and services, and even developing new value propositions, thanks to the Internet of Things. The impact of this technology may be felt most strongly in the realm of marketing and sales. Companies may acquire large amounts of data about customers and potential customers in real time, thanks to the Internet of Things, allowing them to respond more quickly to their wants and preferences. Previously, such data and variables could only be obtained by intuition or market analysis. The Internet of Things is having a significant impact on the marketing industry. By making it easier to listen to customer requirements and respond properly, IoT technology is assisting businesses in making their products and services more appealing to consumers. Savvy business owners, managers, and marketers are taking use of this groundbreaking technology to deliver the correct marketing message at the right time on the right device. Because IoT allows businesses to acquire more data from customers, it allows them to effectively sell their goods and services. This information is useful because it provides insight into consumer behavior, making it easier to successfully promote products and services. Indeed, some industry insiders believe that the Internet of Things will transform marketing in a year or less. Sensor technologies offer easy tracking of practically every element of human interactions and the environment through real-time data collection and analysis. Businesses now have access to next-generation insights and development tools thanks to data IoT devices. Customer interactions are better maintained, and business process optimization is now easier. These are some examples of how the Internet of Things helps us develop a market. Smart homes stand amongst the most popular consumer IoT devices and service providers currently in development. The major reason is that many IoT devices in this category are easily affordable and readily available. It's exciting how you can control everything using a smartphone application such as Amazon's Echo and the Nest thermostat, alongside many products on the market, allow users to control their surroundings with their voices and make their lives more connected. Watches now do more than just telling time. Smartwatches now flooding the market have turned people's wrists into smartphone holsters and allow phone calls and more. People can easily monitor their health and variations in body conditions with many IoT devices. Wearable Internet of Things connected devices make it easy to monitor a patient's health and reduce emergency doctor visits. People with special conditions and the elderly can use specific IoT devices to live life more independently and improve comfort. Augmented reality, AR, in the Internet of Things is the digital simulation of the physical world. AR is a growing trend among business application and mobile computing companies. They use digital visual elements, sound, or other sensory stimuli delivered through IoT technology. These are the top Internet of Things companies.
Environmental monitoring is the most beneficial IoT application. It uses advanced sensor devices to identify the presence of pollutants in the air and water and promotes better sustainability. You can keep the premises safer and cleaner by utilizing a smart environmental monitoring solution. In closed-space workplaces, such as underground mines, office premises or rooms, it becomes necessary to maintain a favorable atmosphere. The air data is captured through sensors and is sent on a cloud platform through gateways. Organizations can easily collect the information in a user-friendly format via a connected dashboard and analyze it for better outcomes. Many environmental trends are complex and difficult to conceptualize. There are many challenges to using traditional techniques to monitor environmental conditions. With the advent of the technological era and smart management strategies, it has become easier to keep a real-time check on people's surroundings. Water is the most essential resource for survival. It requires constant quality monitoring and proper management techniques for effective conservation practices. IoT technology enables smart water meters, sensors and irrigation systems deployed in homes and smart buildings for real-time monitoring of the water consumption patterns. Also, Advanced sensor devices are installed to measure the pH levels, oxygen levels, and other components, such as contaminants that might be unsafe for drinking purposes. Detecting such parameters offers reliable use cases that are beneficial to promote better human health and contribute to enhanced living standards. In the environment, air quality has to be pure and healthy for breathing, otherwise, it could lead to major health issues. Even while working in a closed space area, the surrounding air should be clean and fresh. IoT-powered environmental monitoring solutions, when installed for particular premises, can be used to identify the particulate matter in the air and capture the data through sensor devices. Organizations can transfer the data to a cloud platform for processing. Useful information is sent to the user's dashboard. The whole process enables real-time air monitoring, quick decision-making in case of any issues, refreshing air, and controlling ventilation for better air circulation. IoT-powered products are cost-effective and can be implemented to improve the ambience. The sensor-based technology is the most effective for purposes of cost savings related to energy consumption and optimizing worker productivity. A smart environmental monitoring system provides all the details of the energy consumption patterns and the areas where energy is used unnecessarily, making it easier to reduce energy use. Also, with technological advancement, the sensors have overtaken the traditional ways of switching the lights on and off. With the use of an IoT-powered solution, you can remotely control energy use, thereby conserving resources. IoT for environmental monitoring is the most appropriate way to have remote control of our surroundings. Closed spaces are often exposed to harmful gases, which can cost infrastructure and human lives at larger levels. However, pre-detection of such harmful gases provides a clearer picture of the future happenings and can reduce the destructive effects at a significant cost. The sensors and gateways are the key components that enable automated and real-time identification of such gases, which in turn, provides a track record of the data for analysis, allowing predictive results. IoT has become a major part in providing safer and cleaner surroundings. Installing a smart environment solution can provide a better approach to air quality detection. It helps organizations evolve with the latest smart technology trends, which offer efficient industrial improvements and increased ROI. Monitoring the environment through smart concepts provides better control over the surroundings for a safer existence.
Internet of Things or IoT can be applied into many different things in everyday life, healthcare, cities, agriculture, industrial automation, disaster management, and more. First, we have Internet of Things in our daily lives. This is probably a hallmark in the IoT industry as it's also one of the first industries to deploy IoT added service. So let me give you an example of how IoT can serve us in our daily lives. Consider a home appliance such as your air conditioner. Currently, what we do is turn on your AC and wait for it to reach a certain temperature, say about 26 degrees Celsius. This is a perfectly functional setting, but what if it could be improved? Let's say you're out of your home and your car was 5 minutes away, and your AC received a message. What if it was connected to a cloud which had a dashboard containing all the relevant information like the location of your car, the outside temperature, and the temperature at which you like, and you can then turn on the AC before you arrive and create an ambience ready for you once you get home? Just a figment of your imagination of the technological world thanks to the Internet of Things. IoT can connect your vehicles, smartphones to your in flight services from home appliances to whole entire cities, our everyday lives. Next, we have IoT in healthcare. Most people probably have heard about the smart medicine dispensers by now. As the name suggests, it's basically a smart appliance that stores, dispenses, and manages your medicines for you. Now, this is just a small piece of a very big picture. The healthcare and the general practice of medicine majorly faces issues in one or more of these three things. Medical research has to rely upon leftover data in controlled settings for medical examination. It lacks real world data which can solve critical conditions. IoT could be the answer to all these problems. IoT opens ways to a sea of valuable data through analysis and real time testing. Internet of Things empowers healthcare professionals and improves the quality of care. Finally, it ultimately reduces the unsustainably high costs of medical devices. Here's an example. This is basically an outline of how a care device works. A device has certain parameters that are considered safe. Once one of them is breached, the sensor immediately relays this message via a secure gateway to a cloud. Now, it is vital for this gateway to be secure as it holds all valuable medical records. The cloud then passes a remote signal to a smart device that is monitored by either by a nurse or a caretaker at home. The beauty of remote patient monitoring is that patients can now replace a long wait at the doctor's office with a quick data share and instructions on how to proceed. IoT hence bridges the gap between reading devices and delivering healthcare by creating a systems rather than just equipment. Another good thing is that connected devices have a huge advantage over the technology used, as they can leverage user feedback to almost immediately updated software. The bigger the community, the more reliable these devices become. Now, moving on to one of the most talked about prospects of IoT, cities being the smart cities. Now, the thing about a smart city is that a smart city solution is very specific to that one city. Even global issues such as waste control, traffic management, availability of drinking water, housing, and pollution impact different cities with different intensities. So, the only way to really make a city smarter is to cater specifically to its own problem. One such problem consistent among urban cities is traffic. Imagine an intelligent device like a camera that can monitor the road of traffic jams, accidents, rains, etc., and communicate that status to a gateway. Now, this gateway also receives data from various other cameras from all around the city. This in itself could form a citywide traffic system. Now, where can we use it? Say, the municipal corporation has decided to repair a road which connects to a highway for more than one city. Now, this could cause a massive congestion. A smart camera could send this insight to the citywide traffic system. Now, considering this is a smart traffic system, it quickly learns and predicts patterns in traffic. It will analyze the situation and predict its impact and relay this information to other cities that connect to the highway via their own monitoring systems. Now, the traffic management systems then can derive rules for cars around this project. Live instructions could be sent to drivers via radio channels and their respective smart devices. What a bonus is that if there is a school or an office building which has no other way but to use that road under construction, they can be automatically be called, serving as notification. This then creates a network of dependent systems which leverage real time control. And this is just one example of the potential benefits of IoT application. Next, we have a sector which is most neglected despite the importance it holds, that is, agriculture. Manual handling often results in loss of energy, labor cost, and other inaccuracies, which make all its processes less effective. Internet of Things here can provide with a number of solutions. Precision farming, smart irrigation, and smart greenhouse are a few to name. The first two cases are pretty similar, as in both cases there are sensors detecting various parameters at each level of the soil shown here. We have moisture content, temperature, and weather conditions. One can tell the correct depths, so the crops are at the right time to be watered. But one of the more intriguing solutions is the smart greenhouse. So, if we could use embedded devices in these greenhouses, we could not only just monitor it regularly, but we could practically control the climate inside the greenhouse. How the system works is that the sensor sends various parameters and areas of issue inside the greenhouse. They then relay the information via connection gateway to the cloud, which then sends remote commands via the same gateway back to the sensors. So once these signals are acknowledged, they are passed on to the switchgear, which then activate the lighting pumps and turbines inside the greenhouse, creating an artificial sunlight and sometimes artificial precipitation inside the greenhouse. What more from the connection gateway, as you can see, there is a monitor through which 24/7 real-time monitoring has come into effect. Also, you could use any smart device to monitor the conditions inside the greenhouse. With eliminations of irregularities and human errors, this creates a much more efficient system. Another domain where IoT could prove to be a game changer is one of those fields where both faster developments as well as the quality of products are the critical factors for a higher return on investment: the industrial automation sector. But there are still a few problems that needs to be addressed in this sector: inconsistent data entry, time consumption, training costs, security, and even more. Internet of Things improves the line of command immensely. It optimizes packaging and makes quality tests so much easier to run. What more you don't have to worry about is the staff training costs or staff going on a holiday because these factories pretty much run on their own. You can monitor the supply chain in real time while keeping an eye on your inventories with IoT applications. One could even engineer products and their packaging to deliver better performance in both cost and customer experience. Now let's look at disaster management. Now, IoT cannot stop these disasters from happening, but it surely can help in preparedness and resilience during work due to high population density, pure evacuation infrastructure, and exposure to severe weather events. Developing countries are more exposed to the risks of natural disasters and often have limited means to sustain the effects. As a consequence, according to a study, more than 95% of all deaths are caused by a disaster occurring in developing countries. IoT can compensate for this by prediction, preparedness, response, and recovery to rescue developing and emerging countries from their vulnerable positions. Let me give you an example of a forest fire where IoT could be used as a solution to be prepared. For critical incidents, forest fire sensors are installed near the perimeters of the forest. They contribute to data feeds about temperature and carbon emissions to control room, which is common to the entire town. This is done via secure network gateway in real time. They anticipate problems and put defenses in place to mitigate the impact, namely the police, the nearby hospitals, and most importantly, the fire brigade. If such an emergency occurs near urban areas, people and communities are alerted via social media, conventional media channels, and SMS. Now that we've gone through a few applications of IoT, let's move on towards future scope. Now, in just 1 year, internet connected devices went from 5 million to billions, but there are still a few areas that need work. The devices forming the base of IoT are wireless in nature and reside at the very remote places where energy is a very vital issue. So, with growing functionality of each device, we need algorithms and hardware that are energy efficient. To avoid quick draining of batteries, we need to make sure that sensors are active for longer durations. Although IoT has started to adopt solar energy for this. Like any other advancement in technology, even IoT security is a standout issue. This issue keeps getting bigger, with more and more devices being connected to one another. We need information seclusion methods to benefit end clients and secure that data and privacy. Better cybersecurity technology keeps growing to this day. It will be really tough to implement the anytime concept of IoT in reality, but this needs continuous work. And the closest we can get to this is only by reducing the complexity of each existing time systems. We need to do continuous work to reduce the gap between near real time and actual real time. IoT applications promise to bring immense value to our lives. In fact, the number of openings for IoT professionals is at all-time high. IoT is peaking it way even through the government, education, and even law enforcement. So it would be best to begin exploring the true potential of this technology.
Our last subtopic is IoT's advantages and disadvantages. Let's first talk about its advantages. IoT saves us a lot of time and minimizes human effort through automation. IoT devices are connected and can communicate with one another to perform tasks without the need for human intervention. Next, it helps us easily access the information we are looking for, even if we are far away from the actual location, because this information is being updated frequently in real time. Third, electric devices are directly connected and can communicate with each other using a controller such as cell phone, which results to efficient electricity use. IoT also provides personal assistance and can alert you to your regular plans. And lastly, it is useful for safety because it senses potential danger and warns its users. Now for its disadvantages, hackers may gain access to the system and may steal personal information. Next, IoT devices rely heavily on the internet and are unable to function effectively without it. Third, with the complexity of the systems, there are many ways for them to fail. And lastly, unskilled workers are at high risk of losing their jobs as they are being replaced by IoT devices.